Okay, so we have already discussed about probability and 3D, three-dimensional geometry. Okay, most of the theory part I have, the explanation part I have already explained you, and I have uploaded, and you can refer it whenever. Like now, I will try to solve some numericals. So today we will solve some numericals on conditional probability and Bayes theorem. Okay, so the theory related to it I have already explained you. You can refer those. I have uploaded those videos also, so you can refer those videos if you want to know how those formulas are derived. Okay, so to solve something on Bayes theorem, first of all we should know what is conditional probability. Okay. So we'll do some numericals so which will help you to understand it better. Okay. First we'll understand what is conditional probability. Okay. So let us do a numerical, then you can appreciate it bit better. Okay. So we know the formula for conditional probability. So yeah. So P E given F is equal to P E underscore sorry, E intersection F divided by probability of F. Just remember, whichever is the in the second term will remain in the denominator. Okay. So here the condition is that PF is not equal to 0. That is obvious. It should not be equal to 0. Okay. So how this formula is being derived, you can refer to my previous videos that I have uploaded on probability. Okay. So let us try to solve a numerical on conditional probability. Okay. So there are assume. So the question is there are 10 cards. Okay. There are 10 cards. Okay. That those are placed in a box, mixed up thoroughly. Then one card is drawn randomly. So there are 10 cards. You are drawing one card randomly. Drawing one card out of 10. Clear?
Yeah.
Okay. If it is known that the number is on the drawn card is more than 3. Okay. So one condition is that the number on the drawn card
Is more than
is more than 3. More than 3. That means the card can be like
4,
it
5,
is yeah,
6.
it's more than 3. Okay, so it can be 4, 5, 6, 7, 8, 9, 10. Okay, so this then what is the probability that it is a even number? Okay, what is the probability that drawn card is even? So that is our question here. Okay, so here like we can define like the sample space. Okay, so the sample space here is it can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's sample space is the full thing.
Yeah.
Okay, what is possible. Okay, that is a sample space. Then we can define two events here. Okay, let us say
more than
हाँ,
3 and even.
हाँ. Let us say, or this also can be written as, let us write it as A B also. Okay, A B. So probability of A intersection B
Given
divided
that
by
B.
probability of B. Okay. So let us say the sample space is 1 to 10 here, and probability of B. Okay. So let us say probability of B is like B, event B. Okay.
Yeah.
So event B is nothing but 4, 5, 6, 7, 8, 9, 10.
10.
So this is the event B. So once the event has occurred, like once the event has occurred, what is the probability of event A?
Yeah.
So event A is what? Like it's a even number and it's greater than 3.
Yeah. Probable.
So you have already drawn the card. Okay, you have already drawn the card.
The condition is it is more than 3.
First you have drawn the card. Okay, so the card is drawn, but you are imposing a condition that it is even. The card which is drawn, is even and more than 3. Okay, first it is more than 3. Okay, the card which is drawn is even and it is more than 3. So the second condition, first it has to satisfy the condition that it is more than 3. Okay, and it is not only more than 3 but also even. That means first it has to satisfy the condition that it is more than 3. That means this first it has to satisfy this condition B. Then what is the probability that it is even also? Okay, it is more than 3 and also even. So in that case, it will be even. So that when it will happen? So this number, this number, this number, this number, right?
Yeah.
So that even condition, it will be 4, 6, 8,
10.
8, 10. So okay. So there, 4, 6, 2. Okay, so they are saying, okay, so the probability of A is not, we will derive that, afterwards we will derive that. But probability of A is that it is a even number. Okay. So, I means A
You have
is,
to take intersection event.
afterwards we will do it. But first, what does the number of elements in B is this, number of elements in A is that it is a even number.
2, 4,
Okay.
6, 8.
2, 4, 6, 8, 10. So it's a even number is 1 and B is it's more than 3. Okay. So the sample space is 1 to 10. And it's a even number. The elements and the what do you call in the sample space? Those
Elements.
those are called events or elements? Events.
No, events is A and B.
Okay. So now elements. Okay. So elements in the event A is 2, 4, 6, 8, 10. That it is a even number. Okay. And elements in
Sample space B is 4, 5.
not sample space, in event.
In event
Okay.
B.
So elements in event B are 4, 5, 6, 7, 8, 9, 10. Elements in event A are 2, 4, 6, 8, 10.
Yeah.
So you know that there are 5. So probability of A will become 5 by 10 because it will be the event divided by the sample space. So 5 by 10. So probability of B is
6 by 10.
1, 2, 3, 4, 5, 6, 7. 7 by 10.
10.
Okay. So now we know probability of A is 5 by 10. Probability of B is 7 by 10. Now the question is, what is the probability of A given B? That means already B has occurred. Okay. So what is the probability of A given B? That means it will be a even number, but it has to be more than 3. So first B has already occurred.
Yeah.
So if B has already occurred, what is the probability that it is even? Right?
Yeah.
So that is called conditional probability. So probability. So we'll solve it. So conditional probability is that finding the probability of something with the condition that something else has already occurred. Okay. So here we can write it as P A given B is equal to P of A intersection B divided by probability of B. So we have got PA and PB, and what is the intersection? So intersection between A and B. Okay, so A and B, what is the intersection? So you can see here 4, 6, 8, 9, 10, and here here also 4, 6, 8, 10. Okay.
Yeah.
So here 4, 6, 8, 10. Here 2, 4, 6, 8, 10.
Yeah.
So what are the common things? There are 4 common things.
Yeah.
So probability of A intersection B is nothing but 4 divided by the sample space, 4 by 10. Right? So 4 by 10. So now I know this is 4 by 10, and then
P of B is 7 by
P of B is 7 by 10. Okay. So this becomes is equal to
4 by 7.
Okay, so this is the answer. Okay. So now you understand what is conditional probability. So A given B. So already B has occurred. Okay. So that one will come in the denominator. That B, the second term which has already occurred, will come in the denominator, and the intersection of A and B. That for finding intersection of A and B, you have to find A and B.
Yeah.
Then you will see which are the common between them. That is the so once you know the events, then you can find out. Once you know the elements in that event A intersection B, you can find its probability by dividing with the sample space, and then you can do. Okay.
Yeah.
You can take a picture of this. We will do one more numerical on conditional probability. Okay. So we'll do one more numerical on conditional probability. Okay. Okay, so let us do one more. Okay, so uh, consider an experiment of drawing a card from a deck of 52 cards. Okay, so we have a deck of 52 cards. Okay, 52 cards.
Yeah.
So uh, in which the in which E and F denotes events of card drawn in spade. Okay.
Okay.
So let us say E is an event that card drawn is paid. Okay. Then we have another event.
If
Card drawn is S. Okay. Card drawn is S. Okay. So your spade is something like this, right? This one, right?
yeah,
This one is your spade. So so you have 52 cards. Okay. So you will have 13 spades,
yeah,
right?
13 by
You
52.
will have 13 spades. Okay. So your probability of E will be 13 divided by 52. And F is card drawn is S. Okay. So probability of F will be, there will be 4 S.
4 S's.
4 S's. So that will be 4 by 52. So this we know. Okay. Knowing this, find the probability that the card drawn is an S. Okay. What is the probability that card drawn is an S? That is conditional probability.
Given that card drawn is a spade.
What is the probability that the card drawn is a spade, given that it is S. Okay. Is spade, given that it is S. Okay. So first is it is already S. Okay. And after it satisfy the condition that it is already S, what is the condition that
It is spade.
it is spade? Okay. So that will be probability of E given F. Okay. So F is already it is S. So it will be like probability of E intersection F
By probability.
by probability of F. Okay. So now what is E intersection F? Okay. So E intersection F will be only 1 by 52, because you can have only 4 S. So out of
4 S's, only one is spade.
Only one.
One is
Only
spade.
one can be
Ace of spades.
Ace of spades. So it will be 1 by 52, right?
Yeah.
So 1 by 52 is your intersection. So we can say probability of E intersection F is equal to 1 by 52. Okay. So you will have, like say S. So you will have 4 cards. Okay. You will have 4 cards. Okay. So these are all S, 11, 11, 11, 11. And here this is diamond, and this is club. Okay. So, and this is your S, this is your this thing, and this is your heart, right? Right, like this. So these you have 4 like this. So out of this, only one, this one is the S. So its probability, which is probability of E intersection F, is equal to 1 by 52. Okay. So so you know now E intersection F is 1 by 52, and probability of F is 4 by 52. So the answer is 1 by 4. Okay. So this is the probability. Okay. So this is the probability that after S will be a spade.
Yeah.
S will be a spade. So this is the probability. Okay. So we have solved 2 numericals on conditional probability. Now you understand what is conditional probability.
Yeah.
So the probability of an event with the condition that some other event has already occurred.
Yeah.
Okay. So we have solved 2 numericals. So this kind of numericals you can easily solve. Okay. Okay, so with these as background, we will do some numerical on Bayes theorem in the next class. Okay? Okay, thank you.